So I'm just turning on the recording right now. My apologies. I will miss that part. So let me just catch up the video for the recording. What I've done here is I've added a new Java class called Athlete to our advanced classes package. So we've added the Athlete class to that, not an interface, a class. We're going to say that the Athlete class extends the Husky class. And now I can show it in this diagram here that Athlete is a Husky. Okay. Now it's also being used, it has a relationship with our testing class. So let's also bring that into play. So an athlete let's just shorten that to a block equals a new athlete. Okay, so now we're using the athlete class inside of our testing class. But let's back up here to the athlete class. It's extended Husky. So what about its constructor? Okay, let's take a look at the Husky constructor. Our Husky constructor, name, age, and student number. And you know what? I think I'm going to want that exact same constructor in my athlete class. So I'm going to replace the constructor I have right here by copying and pasting the Husky one and then changing the name. So that when I make an athlete, okay, the student number for this Husky high school athlete. Okay, athlete is now also been incorporated into this level of inheritance going on here. Okay, so like the Husky, which represents a Husky, the athlete, a athlete, Husky high school student person. So there's quite a bit of inheritance there. Athlete inherits from Husky, which inherits from high school, which inherits from student, which inherits from person. So we have several levels of inheritance going on. You can also see this in the diagram. Athlete inherits from Husky, which inherits from high school, which inherits from student, which inherits from person, which ultimately inherits from object. So all the methods in object, which were inherited by person, all the methods in person, which are inherited by student, all the methods and properties by student, which were inherited by high school, which are inherited by Husky, are now inherited by athlete. Multiple levels of inheritance going on here. So now back in our testing class, I no longer have a default option. I have to give it a name for my athlete. Let's make our athlete, what did we call our Husky back when we made our Husky? Did we actually give it a name? I don't care. When we made our Husky, we called it Havoc, right? So let's call our athlete, I don't know, let's give it a jock name, right? I don't know. Who's a jock? How about you guys suggest a name? I'm going to put on my, what would be a name for our jock athlete? We'll make the athlete 17 and we'll give it student number, I don't know, 99, like it's Wayne Gretzky. All right, let's call it Wayne. There, I'm going to call it Wayne. That's going to be the name of our athlete. Wayne Gretzky is going to play for, he's going to be an athlete who plays for the Huskies. I can't spell Gretzky. Sort of how it's spelled, but anyways. Wayne Gretzky, 17-year-old who plays, actually, let's make Wayne 18 years old. Okay, plays for the Huskies. He's student number 99. So we've built a jock object, which we built an athlete object through our Husky class. But what I want to now do is I want to incorporate our interfaces, because we haven't done that yet. So we have an interface called sports. Okay. So how is sports, the interface, incorporated into what we've got already, right? It's not using inheritance. I already told you guys that. It doesn't work that way with UML diagrams and with interfaces. Now, of course, I'm just going to show you guys real brief. If you really wanted to get into UML diagrams, okay, and you wanted a guide for how they're used, okay, how are UML diagrams used? There is a lot more to them than what I'm showing you guys now. They are used professionally. You can see examples here, a dog creating a dog object, the note of the sort of the symbols and how they work in very complicated ways. You can see here some of the types of inheritance and dependency type stuff, association. I'm kind of giving you a basic idea of how they work, just a real basic idea of what's going on there, okay? Really basic. With interfaces, you can kind of see right here, the way they create them is they use this weird notation that they put these symbols in with interfaces like this, okay? So an interface, to recognize it in a UML diagram, would look like that, okay? So that's what sports would look like, not to mention hockey and football would also look like that, and permission form. So let me just quickly whip those up. And I don't know if these diagrams are helping or not, but it's a way, another way to learn some computer science other than just writing code. Who knows, for those of you studying computer science beyond high school, if this will come back and be something that shows up in what you're learning later. So I would like that to at least be something that you have some awareness of. Okay. So we've got permission form, football, and hockey, and sports. Now here's one thing I know. Hockey and football inherit from sports. So in theory, I could take one of these types of arrows and show inheritance. Oh, well, sorry, that's not inheritance. This is inheritance, according to my diagram, this type of arrowhead. Spin that. Spin that. Okay. So hockey is a sport. And football is a sport. Permission form doesn't inherit from sports, because that doesn't make sense, right? Okay. But we do have permission form. And they are used in a way by the athlete class, or at least we're going to want them to. But what we want them to do is not inherit. We want to have them implement, okay? And implementing is generally done using this style of arrow. So it's a dotted line, but instead of a filled in arrowhead, it uses just that. So it's going to have this type of line. So athlete will use or follow the rules of, for example, hockey and okay, there we go. So it will use hockey in terms of following the rules of it. It will use football. It will use a permission form. But it's really a different style of using it. It's implementing these things. So we need a different style of arrowhead here. So the style of arrowhead is a sort of a V-shaped thing here. So I'm going to try to create this. Just paste it up here. Okay, you guys are seeing me draw as we're, so flip left to right. There we go. There it is. That's the style of arrowhead for interfaces. Okay. So the athlete class uses the hockey, football, and permission form interface. Now, what's interesting about this is something that you can do with interfaces that you can't do with classes. And I want to point that out in one of the slides I showed you guys. Okay, I want to point out that point to you. That once a class implements an interface, it must implement all the methods. That's like abstract classes. But interfaces can, you can implement multiple interfaces. That's what it's saying right here. You can implement multiple interfaces from one class. You can't do that with inheritance. One class can only inherit from one other class. But with interfaces, it's a way around that. So here's how this is going to work. We're going to go back up to the signature line of our class. Husky, or athlete extends Husky. And then we're going to add the word implements. That's a key word right there. Okay. And now we can list what we're going to be implementing. So for example, we're going to be implementing hockey. Okay. So the athlete class implements the hockey interface. It follows the rules of the hockey set of rules. Let me put that in as a little bit of comment up here. Okay. Using keyword implements in the class signature line means this class follows the rules of that interface. Okay, it's following the rules of hockey. This will programmer to implement and that just means the methods that were suggested in that interface. It's just like an abstract class. It's going to force this on us. We now need to write these methods. So this in NetBeans the light bulb. So you may have noticed this light bulb has appeared here. Okay. So I can use this light bulb to implement all the abstract methods. Okay. So maybe I will add the word abstract here in terms of methods. That might make it a little more clear that that's the type of method we're talking about here. It's an abstract method. Okay, so I'm going to do that. Light bulb, implement all the abstract methods. That fixed the potential error in our athlete class. And then waiting for us later will be us writing these methods. They have to be written now. Now you'll notice that the methods that came in from the hockey class. So that means score and end of period will be there, right? Oops. Athlete now has score and end of period. But it also wants us to implement these three methods. Where did those come from? Well, remember, hockey comes from sports. And in sports, that's where those three methods are, those three abstract methods. Okay, so that's how it works with interfaces. But what's really cool about interfaces is you can implement, and remember what that means is follow the rules of giving me an error there. Just a comment, there's no need for an error. can implement multiple interfaces. This cannot be done with classes. One class can only inherit from one other class. Can't have, like, say, our person class say person extends this class and it extends another class. So inherit, what I meant there was extends. That can only be one. Now, as a side note, this is different in other programming languages. In some other programming languages, you can do multiple inheritances, but not Java, and actually not most modern programming languages. There was a lot of potential issues with multiple inheritance. But to do this, do multiple implementation, use a comma between spaces. Okay. So that's a big comment explaining what I'm about to do next. Hockey, comma, football, comma, permission form. So my athlete class is a husky. An athlete is a husky, but that husky follows the rules of all of these sets of rules. That's a way you can read that line now. Okay. Now, because I've now put in two more sets of rules, I've got more methods to implement. Implement all these abstract methods. So now waiting down below for me is a bunch more methods that I'm going to need to fill out. Okay. So we're going to fill those out, but I'm going to take a second to put this up on GitHub for those of you that might be sort of following on GitHub. Why is GitHub not showing up? Git commit. Because this class might be, that comment is a bit daunting that I just put in there. And so I want to make sure that that's there for you guys. There will be an error for now. We're going to fix that error when we fill in the methods. Next, finish. Okay, so what you guys could now do is if you go to GitHub, you should now find this class called athlete. And in athlete, you should be able to now grab that comment to help you explain what this implements thing means, what interfaces essentially mean. Okay, so now we just got to fill in the details of how the athlete class is going to work. So to do that, we're going to need a few properties for this class, for the athlete class properties. They're going to be private. They're going to be encapsulated. A Boolean. Do they have their permission form? Encapsulated property. Right? It's only available within the athlete class. Have they permission form? Their opponent. Who are they playing when they play an athletic event against? We'll keep that stored. The score. How many points the athlete has. And we're also going to need to keep a score of how many our opponent has. So to help sort of clarify this, I'm going to call this one opponent score. I'm going to call this one opponent name. I'm going to call this one our home score, because that's often the way they're listed in athletic events, the home team and the opponent team. Okay. will be our properties. All of them will be encapsulated, okay? Does this athlete have a permission form? Who is their opponent? What's their name? What's our score? And what's the opponent's score? So by using these properties, we can now fill in our methods, okay? Starting with our constructor. With our constructor, having a form equals, well, we don't have our form. But to draw that in, I'm going to go permission form dot, and here are my two global static shared properties. An unsigned form is what I have. I have a not signed permission form. Okay? My opponent name will be nothing right now. My opponent doesn't have a name yet. A score, the home score, is 0. The opponent's score is 0. So I've set my properties those internal encapsulated properties to default values. So they're set to defaults. So not signed, no name, 0 score, 0 score. Now I'm going to ignore toString. I'm going to leave it, but toString equals clone. But I am going to deal with score now. Okay, so somebody has just scored a point here. So how am I going to code that? Well, I'm going to do an output here. Okay, so if they're going to score, well, then I'm going to say that this name has scored a point. Okay, that's going to happen. But also, if they score a point, I have to give that point to somebody. So I can use a little if statement. If the name dot equals, okay, my opponent name, then my opponent score by 1. My opponent just got a score. Remember, score is a method from the hockey class. And in hockey, you always score 1 point. So my athlete in hockey has just scored a point. Why don't we actually just say a goal? That's what we call it in hockey. That person scored a goal. Okay. Now, how do I access my name if the name equals my name? Well, my name is part of the superclass. And name has been something that we've been inheriting all the way back from person. And name was originally a public property. So that's easy for me to access. And I just have my home team score go up by 1. So that's how I'm going to score in hockey. Okay. And if you're wondering, like, how do I comment this method? Well, I could actually just take that comment right from the hockey interface and paste it right in there if I wanted the comment. Now, while I have this, let's go down to scoring in football, because scoring in football is a little bit different. This one involves points as well as the name. So it's going to be basically the same method. So let's copy the same code over to score in football. But we don't call it a goal. We're going to say scored this many points. It might be different values. And instead of just plus plus, I'm going to say plus equals, add on the points. Okay, to either the opponent or the home team is going to add on points. So that's how I score in football. So in football, when I score, it's a little different than scoring in hockey. That's how I score there. All right, so that takes care of 2 of our methods, scoring in hockey, scoring in football. Now let's go up to set name. We'll skip end of period for a second. Set name is actually pretty simple, right? How do I set the name of this particular object? Well, set name, you might remember, is a method that we got from the sports interface. One is to set our name, one is to set the opponent name. So let's do the opponent one first. All I do is I say opponent name equals name. All I need to do. For set name, I use super.name equals name, so that the code is more clear as to what's going on there. So that's how I set the name. So take that comment, and I'm going to shorten it down to just that. And setting the opponent name would be just that. Okay. Notice these are now overriding the ones from the interfaces. All right. Did I win? And sign, and have you got it signed? Let's take care of those ones because those are pretty simple. To sign this permission form, I'm going to do a little output, and I'm going to say super.name has gotten it signed. So they've just signed their permission form. They've gotten it signed. But I have to change that. Have form now has to be equal to true or permission form dot signed. That is, that property represents true right here. So I'm just using the code I have to lock it in that way. This is me using the sign method from the permission form interface. Interfaces is a way to start putting the code together with these things we've set up. Have I got it signed? Well, for that, I just return that have form property, the one that I use there. So in a similar way, I can just use that comment and finish up have you got it signed as well. So there's sign and have you got it signed, all done, very little code. The two methods left to do, three methods actually, end of period, did I win, and end of quarter. Let's quickly whip those up before we're done. Now I realize I said I would go to 11:40, but I do want to kind of get this done before the end of the period. So I'm going to keep going here. So how am I going to do the end of a period, okay, in hockey? Well, to do this, I'm going to make a little string called output. And I'm going to say, you know what? This string equals the words. It's the end of period. And then at the end of this, I'm going to output. So I'm going to spit it out. But I think I'm going to add a little more to output. Output plus equals. So I'm going to add some information onto this, right? So it's not just going to be that. I'm going to add a few more lines to my output. So for example, I'm going to say, and the score is home score for the name and the opponent score for the, and I'm going to attach my opponent name. So you can imagine it says like end of period 1 and the score is 10 for the Huskies and 5 for the Pipers or something like that. Okay, so just adding a little bit of extra spacing to make this code a little bit more readable. That's what I kind of want to do, is put that into the end of this period. I will use basically the same code for the end of a quarter in football. I'm just going to pop that comment in there. I'm going to take this exact same code over to the end of a quarter and grab my comment from the football interface. A lot of copy pasting. And I'm going to say end of quarter here and switch the variable name to quarter. So it's end of that quarter for the football one. Okay, but the score stuff is still the same. So the end of a period or the end of a quarter, depending of whether we're playing football or hockey. Okay, the final method to do. Did I win? Did I win this particular contest? So this is actually also pretty simple, because if the home score is greater than the opponent's score, then we win. Okay. Dot name, that team wins. And I'm going to return true, that we won. Otherwise, we didn't win. Okay, we either lost or we tied. I'm going to say name does not win. Okay, so they either win or does not win. Or maybe what I'll do is let's forget ties for a second. Let's change this to our opponent name wins. And we're going to return false because we didn't win this particular thing. So this is a method that returns true or false. Did I win? Well, if my score is greater than the opponent's score, then I win. Actually, let's say we win even with a tie. So we'll say greater than or equals to. Then I win. Otherwise, my opponent wins. And the did I win method came from the sports interface. And so that completes our athlete class, including all these inherited methods that we were forced to write because we were implementing 3 interfaces. We also implemented, or pardon me, extended a Husky interface. So now, with all of this in place, let's just use our athlete class in our testing class. We've created a jock. Let's run a for loop using something called round as our variable. Let's run 4 rounds. Okay. Let's have our athlete in 4 rounds of athletics. Okay, let's check if they can even play this round. If rock dot, have you got your permission form signed? Well, if they don't, get it signed. Let's get them to sign their permission form. Okay. Now, if they do have it signed, they can play. Then we'll have them play. But down here, we're going to have them sign. They can play. So for the first round of this athletics, they couldn't play because they didn't have their permission form signed. So now they're going to sign it. So then the next round, okay, so let's do a little output here. It's round. Dot. So for round 0, we're going to have them sign their permission form. Now they can play for the next round. I know, okay, give me a second. If you guys have to log off, go ahead, but I'm just going to record the rest of this video so it's online. We're going to have our jock dot set their opponent to have them face the Pipers in hockey. Let's have our jock dot score. They're playing hockey. Let's have them score 2 points. Or sorry, they're a score for us, which is the Husky, right? Our name, or sorry, Wayne is going to score. And then we're going to score. Remember, score is overloaded. So this would be football. We're going to score 3 points, a field goal, but that would be for the Pipers. Okay. And actually, let's switch that. Let's have Wayne. No, that doesn't make sense. Pipers score 3 points here. Okay. Let's have our jock dot. What other methods could we incorporate? Well, we can score. We can do all kinds of cool stuff. But let's have it be the end of the period for this round. Have it be the end of the quarter for this round. And let's run that. Let's see if we can get our athlete to play some sports here. There we go. Wayne has scored a goal in round 3. Okay. Et cetera, et cetera. And let's end this. Let's check if we won. Okay. Did we actually win this thing? Well, if our jock dot did I win, and if they won, I have my jock dot consume. I eat a steak if they won. And unfortunately, I think the jock is not going to win. It's the Pipers that are going to win because the Pipers are scoring 3 points where we're only scoring 1 point. So let's change that. Let's have Wayne Gretzky score a hat trick. So they score 3 points. Even though the Pipers scored 3 points, let's actually make the Pipers only score 1 point, like a touchback in football. And now we win, Wayne wins, and eats the steak. It was savory. Okay, I'm going to wrap that up on the video now. Thank you for those of you who stayed with me for those last few minutes. I'll see you tomorrow.